Huh? Karin, can you hear me? Can you hear me, Karin? Can hear or not?
Yeah, so
Uh,
yes.
can, huh? Okay, can hear. Can see the screen or not? The curve, the area under the curve?
Yes, yes.
Okay, okay. Anybody coming in? No, nobody coming in yet. Any more coming in? Okay, Li Liu Ying. We wait about two more, for two more to come, then we start. Okay, it's already 1:46. Any more coming in? Neighbor waiting room, share screen, chat, rename themselves, remove participant report. Okay, okay, no more. We start. Okay, the topic for today is area under the curve. Now, if you look at the screen, can you see the screen or not? Yes or no?
Yes, sir.
Okay,
Yes, sir.
yeah. So if you look at the screen, I have drawn two curves here, one on the left and another one on the right. Okay, the one on the left, this one. See, this is part of the curve. Now, when I say area under the curve, it is the area bounded by this blue line with red dots there and the x-axis. Okay, the area between the curve and the x-axis. Now, there's another type of area. You look at the diagram on the left, on the right. This is the curve. This is the curve, and this is the y-axis. If I say the area between the curve and the y-axis, I'm referring to this shaded part here. So it's between the curve and the y-axis, or it is between the curve and the x-axis. So there are two types of area. Uh, the first area here, not only it is bounded by the curve and the x-axis, there's another two boundary here. I have drawn using thick red line. Okay, so one is x equals to a and x equals to b. So these four lines, x equals to a, x equals to b, the curve and the x-axis, the four lines here enclose a certain area, and we have to find that area. Okay, right. So we continue. So in the first case, we are referring to area bounded by the curve y equals to fx, the x-axis from x equals to a to x equals to b. Now this is the shaded area, and this is the area we want to find. And this area is shown by this formula here. Oh, Farish is here. So this formula is given by this area is given by the formula a equals to integrate y dx. Y dx from x equals to a to x equals to b. Now we look at the other type of area over here. The area over here is the area bounded between the curve, the y-axis, and the line y equals to b and y equals to a. Okay, so we look at this area. So area bounded by the curve x equals to gy. Now you look at the curve is slightly different. We start with x equals to gy. So it's a function of y. On the left hand side, it is a function of x. So it's a function of y. Or even if it's not a function of y, we have to make x the subject of formula and make it x equals to y. X equals to y something. Okay. So what is the formula? Okay, the formula is the shaded area equals to integrate x dy from y equals to a to y equals to b. So I keep quiet for a short while. I let you see the difference. So if you have no question, then I continue. So far okay or not? One more time, one more time. I repeat, Okay, so the area on the left hand side is the area between the curve and the x-axis. It is given by area equals to y integrate y dx. Now if you look at y and dx here, y is a different variable, so you cannot actually integrate y with respect to x. So you have to change this y to a function of x. So therefore the area is fx integrate fx dx. So you see that everything is in terms of x, then you are referring to the area between the curve and the x-axis. Between the curve and the x-axis, everything is in terms of x. You look at this one here. Everything is in terms of x. We have to integrate fx dx. You have to integrate a function of x with respect to x. And the upper and lower limit of this definite integral is x equals to a and x equals to b. Everything is in terms of x. Now we look at the right hand side. Okay, we look at the right hand side. The area equals to integrate x dy. So you cannot integrate x with respect to y. You have to convert the x to a function of y. So the area is integrate gy dy. That means you are integrating a function of y with respect to y. And the upper and lower limit, they are y equals to a and y equals to b. Okay, so far, any question? Any questions so far?
No, sir.
Okay, no, no, then I can continue already. Okay, next one. So now this is actually the same, but I'm going to give you example. Okay, right. So we look at one example. This example is we have a curve y equals to x squared plus 3. Okay, now can you see this function here? Y equals to x squared plus 3 on the left hand side. Okay, then the area is between the curve and the x-axis from x equals to 0 to x equals to 2. So these four lines, they enclose a certain area. And I want to find what is this area enclosed by these four lines. Okay, right. So this is the case of area between the curve and x-axis. So what formula we are going to use? Curve and x-axis. It will be integrate y dx. So everything changed to x. Integrate fx dx from x equal to a to x equal to b. Now apply this formula to the problem given here. This one. Y equals to x squared plus 3, x equals to 0, x equals to 2. How to apply? So it becomes like that. Area equals to integrate fx dx. So now I have changed this fx to a function of x squared plus 3 dx. And the limit is also x, from x equals to 0 to x equals to 2. Okay, so next step, you know how to integrate, right? Integrate x squared become x cubed over 3, integrate 3 becomes 3x. Okay, then I substitute the numbers inside, substitute 2 inside, then substitute 0 inside, and you use your calculator to find. So answer is 8 and 2/3. Okay, so far okay or not? Okay, so now you have to compare with the curve on the right hand side. Now this curve on the right hand side is given by this equation, x equals to 3x squared plus 2. And the area you want to find is this shaded area. This shaded area, can you see that it is between the curve and the y-axis? Yes or no? Between the curve and the y-axis. So we are going to use integrate x dy, and everything changed to y. Everything changed to y. The function you change to y. The upper limit and lower limit comes from the y-axis. So how to apply this formula? This is it. Okay. Area equals to integrate 3y squared plus 2 dy from y equals to 1 to y equals to 2. Everything in terms of y. If it is between the curve and the y-axis, everything is in terms of y. So do you know how to integrate this? Yes. Integrate 3y squared become y cubed over 3. Okay. Integrate 2 becomes 2y. So substitute the two numbers inside. Okay. Substitute the first number, you put inside what bracket. Substitute the second number, you put in another bracket. Finally, the answer is 9 units. 9 units. Okay, Yang Wan Li also here. Yang Wan Li is here. Okay, so far, any question? So before that, let me summarize again. Okay, now I have told you there are two types of area, one between curve and x-axis, another one between curve and y-axis. So how to apply the formula that I've taught you, right? Now for the type of area between the curve and the x-axis, everything must be in terms of x. The function, the limit with respect to x. If it is between the curve and the y-axis, everything must be in terms of y. So the function is y, you integrate with respect to y, the upper and lower limit comes from the y-axis. Okay, so compare the two types. Any question? Any question? No question, then
No.
okay, no, then I continue with other examples. With other examples. Okay, right. The other example is like this. Now, the first thing you take note is this one, this one. Between the curve, sorry, between the curve and x-axis, between the curve and the y-axis. The first thing you need to take note. Now, the second thing you need to take note is the area itself. Now, if you look at the first problem on the left-hand side, okay, we have area between the curve and which axis? Between the curve and the x-axis. But again, within the curve and the x-axis, we have two types of area. One is above the x-axis and the other one is below the x-axis. Now, when we try to integrate, the area above the x-axis is a positive number. The area below the x-axis is a negative number. Okay, right. Now, if you add the positive number to negative number, the total value will be what? Very much smaller, or perhaps sometimes if the two areas they are equal, you will get 0. So you cannot integrate from 1, -1 until 4. You will get a smaller number or you get 0. You won't get the correct number. Okay, you won't get the correct area. So what I suggest to you is you break this area, the two areas, into two different parts. The part that is above the x-axis, area 1. The part that is below the x-axis, you call it area 2. So you break them into two parts. Okay. Okay. So next we are going to look at this area here, the area on the right hand side here. Now this area here, you look at the curve is again like that. Now this area is between the curve and the y-axis. Between the curve and the y-axis. Okay, we have two areas here. One is on the left hand side of the y-axis. The other area here is on the right hand side of the y-axis. So we have two areas here. Now again, we look at the shown here, the graph shown here. The area on the right hand side of the y-axis is a positive number. When you integrate, the area you found on the left hand side is a negative number. And if you add the positive number and negative number together, it is possible that you get 0. Then how can it be 0? Because the area cannot be 0. Now, even if you don't get 0, you add the positive number and the negative number together, the result will be a very much smaller number. It cannot be the area of these two shaded parts. So how to tackle this problem? How to take into consideration that sometimes the area can be positive, sometimes the area can be negative. How to take into consideration this? Okay, so let us see. So before I carry on, okay, we look back at the example on the left hand side. Okay, on the left hand side, area between the curve and the x-axis, if it is above the x-axis, is positive. If it's below the x-axis, it is negative. Okay, so for this area here, actually it consists of two parts. For this problem here, the area consists of two parts, and this problem is the question number 3b in the exercises that I've given you. This is question 3b. So I break it into two parts from 0 to 4. So I integrate y dx from 0 to 4. Then another part will be integrate from -1 to 0. -1 to, can you see this? Is it a bit small for you? Anyone? The writing here, is it a bit small? Can see or not?
Okay, sir.
Okay, right.
Yes, sir.
Thank you. Okay, so this is how we are going to find the area. We break it into two parts. The part above the x-axis, we make one integration. The part below the x-axis, we make another integral. So the next, we proceed. Now, the part that is above the x-axis is a positive number, so you don't care. You just calculate and it will be a positive number. However, the part that is below the x-axis, you put a modulus sign there. So this modulus sign will tell you that if your answer is negative, please change it to a positive number. That is the meaning. One more time. The modulus sign there is to tell you that if your answer is a negative number, please change it to a positive number. Okay? Because area cannot be negative, it's always positive. Okay, next. Okay, now I introduce the function into the fx. So the function is like this, right? The function is like this, is given here. Okay, so it's integrate from 4 to 0 dx, integrate from -1 to 0 dx. But for this part, you have to put a modulus sign there. Okay, right. So you expand the function, expand into a single polynomial, like this. Then you integrate term by term. You do not know the methods of integration except that one, the substitution one. So that you only learn two methods. One is integrate a polynomial, and another integrate using substitution, the simplest substitution. Now, if you go to other form, then there will be other types of integration, just like your product rule, quotient rule, function of a function, chain rule. So for differentiation, you have many rules. For integration, also we have, but then at form 5, you only learn this type, integrate a polynomial. Okay, so integrate, then you substitute the number inside, you will get 32. You integrate, then you substitute the numbers inside, you will get -2 and 3/4. So this -2 and 3/4, you change it to a positive number, and you add to 32, it becomes 34, 3 and 3/4. Okay, so far I give you some time to think over first. Okay, right. So if it's okay, then we look at the second problem. Now this second problem correspond to question number 5b in the exercises that I've given you. Okay, 5b. Okay, so again we divide the area into two parts. The part that is on the right hand side, this part is positive. Now although this part is below the x-axis, can you say that it's negative or not? This part here, below the x-axis. Is it negative, this part? Anyone? Huh? No. Now, if you find the area between the curve and the y-axis, so you only look at the y-axis, don't look at the x-axis. So this part here is on the right-hand side. Right-hand side is positive. Now this one, although it's above the x-axis, you don't look at the x-axis. You only look at the y-axis. So the y-axis, it is on the left-hand side. So this one is negative. Okay or not? So we proceed. Why cannot move on? Okay, got. Okay, so the area between the curve and the y-axis. So it is integrate x dy, integrate x dy. We break it into two parts. From 0 to 1, one part, and from -1 to 0, another part. Okay. Now from 0 to 1, terbalik lah. Terbalik. 0 to 1 should be the modulus here. The modulus sign should be here because this is negative. Say please take note. Sorry. Typing mistake. The modulus sign should be here. This is positive and this is negative. Okay. Ayo. Sorry. Terbalik. Terbalik. Okay. Terbalik. The modulus sign should be on this side. From -1 to 0 is actually positive. So this one no need modulus sign. This one you need the modulus sign. Okay. Ayo, the mistake continue until the end. Here I change back already. Okay, can you see that from 0 to 1 to -1 to 0 is positive? Then from 0 to 1 is negative. That's why I put the modulus sign here. Okay, this one I change back. I make the correction. So over here, please take note. Terbalik. Oh, someone please tell me you already take note. Someone please tell me. This one, the modulus sign terbalik. Here, the modulus sign is correct. Someone say okay to me. We already noted this. Okay, where's the chat? Chit chat. Someone please take note. Tell me it's okay. Okay or not? Chat, okay. Okay, okay, you noted already, okay, very good, thank you, thank you. So now this part is correct, the bottom is correct. The top part I terbalik the modulus sign. Okay, so far any question or not? So far any question? Okay, no. Karin said no. Karin said no. Other people? Karin said no problem. Okay. So can I proceed to the next question? Next type of question? So far, how many types? Yes, okay. So far, two types. Two types. Okay, the first type is with the axis, with the curve and the x-axis, curve and the y-axis. Then the second type, above the x-axis and below the x-axis, they have different values. Here, the second one is on the right-hand side is positive, on the left-hand side is negative. So we have two types, okay? Two types. So any other type, I'm going to show you, right? So this is question 6C in the problem that I have given you. Question 6C in the problem that I've given you. Now, question 6C, we are looking at question number 6C. Now, this is the shaded area. Who can tell me, whether you put inside the chat or you answer me verbally, that this area here is the area between the curve and x-axis or the area between the curve and the y-axis? How to proceed? How to find? How to find this area here? You consider this area the area between the curve, or no need to say consider lah. You find this area using area between the curve and the x-axis, or you find this area using the area between the curve and the y-axis. In other words, I'm asking you, hey, this one is the first type or second type? Okay, now you put inside your chat there, you tell me. This question, number 6C. How you proceed, how you approach the problem? Area and the x-axis or area and the y-axis? Which approach you want to use? Anyone? You just type in the chat there. Pick up. You try to think. Try to think. Area and the x-axis. Okay, Karen said area and the x-axis. Anybody else? Area and the x-axis. It looks like that, right? It looks like that. Okay. Anybody else think that this area is, you can find this area by using area between the curve and the y-axis? No, nobody else can answer me. Anybody else want to answer me? No. One more girl, please. One more girl. Please answer this. You want to find this area, shaded area here, using area between the curve and x-axis or between the curve and the y-axis? One more girl just say, tell me. X-axis, y-axis, then I proceed. Okay, x-axis, huh? Okay, right. So I proceed. I show you the picture. Not this picture lah. Ah, yes, this picture. Big and very clear. Okay. And see this picture, huh? Okay, I explain slowly and you listen carefully, huh? Listen carefully. Now, the area that is required by the question is this shaded green color. Now, if you want to find this area between the curve and the x-axis, you are only finding half the area. Hey, the x-axis is until here, you know. So you want to find between the graph and the x-axis, you're actually finding half of the area only. You are finding half of the area only. The other half there, you cannot find. Understand, huh? Right. Then, if you are finding the area between the curve and the y-axis, you are actually finding the blue area here. You are not finding the required area. So how to do? How to proceed? I give you two ways. One way, I integrate from the curve to the x-axis, but the answer I have to multiply by 2. Because you only until the x-axis, so you want below x-axis, you have to multiply by 2. Now another way will be, I find the area between the curve and the y-axis, which is the wrong area. This is the wrong area. This is not the area that I want to find. However, I use a rectangle here. And I minus the blue area, I will get the green area. Okay or not okay? So now you look at the arrow here I've shown. Now if you want to integrate y dx, you are actually finding half this area, right? You are finding half the area. The other half cannot find. If you want to integrate x dy, that is using this function, you're actually finding the two blue areas. Okay or not okay? Understand, huh? Very clear or not? What I'm telling you, is it clear or not? Clear, then I go and calculate for you the area. Yes, you said clear. Okay, then I come back here. Okay, I come back here. So this area here, I make it smaller and I put it over here. Show. Okay, so I have two methods. One method is I find the green area. Another method is I find the blue area. So the green area or blue area, this one, integrate square root of 9x. You see here, if I integrate x y dx, the y is y squared. I cannot integrate y. So I want to make it y become, the y is actually square root of 9. So y dx is square root of 9. And this square root of 9 will give me half of the green area. Then if I want to use the other one, the blue color here, I have to integrate x dy. X dy means I have to make x the subject of the formula. So it becomes y squared divided by 9. Y squared divided by 9. Okay, Liu Ying sure okay one. Other girls, okay or not okay? Other girls.
Okay, sir.
Okay, wow, very good. Can understand, wow. Megan also understand, very good. So this is it, this is so the two sides of the coin, two ways to find the area. Okay, right? Okay, first of all, if I want to use the y dx, I have to find out the where it actually cut. I want to find this point of intersection and the point of intersection here. X equals to 4, then the y is equal to 6 and negative 6. X equal to 4, y equal to 6 or negative 6. So I try to solve the equation to find out the point A and point B. Okay. So I found out the point A is, I better type here. Point A, A is A is 4, 6, 4, 6. B is 4, negative 6. I didn't write down, sorry, didn't write down, so I write down here. Okay, so I found out the 2 points already. So the first method, want to find the green area, but you have to put a 2 in front. Why 2 in front? Because the green area is between the curve and the x-axis. It's only until the x-axis, only this part only, the bottom part cannot find. Okay, so you want to find the bottom part because it is symmetry, so we have to multiply by 2. Can you understand why I multiply by 2 here? When I integrate from 0 to 4, I only find this area. The bottom part I cannot find, so I have to multiply by 2. So the square root of 9x is 3x to the power half. Do you know how to integrate x to the power half? Yes. Integrate x to the power half is x to the power 3 over 2 divided by 3 over 2. Have you learned how to integrate this one? Have you learned how to integrate this one? Okay,
Yeah.
where is Liting? Call Liting, sudah cabut. Okay, right, never mind. So even though it's a fraction, you can integrate, right? So answer is, when you multiply by 2, it becomes 32 units. 32 units. So we look at the other way. Okay, the other way is like this. Where to put? I put at the bottom here. Can see. I put at the bottom here. I make it bigger. Okay. Now the other way will be, the shaded area here, the green color, is the area of rectangle minus the area under the curve. Area of rectangle means this one, this rectangle here, the big one. From the blue line until the green line, go back to the y-axis. So I use this whole rectangle, area of rectangle, minus area under the curve. That means minus the blue color. Then I will get the answer. So what is the rectangle here? Here is 6, here is another 6, then here is 4. So altogether 12 times 4. 12 times 4, right? Then the area is integrate from x dy from 6 to negative 6. Here is 6, here is negative 6, so you integrate from there until here. Okay, so this integral is the blue color, not what we want. X cubed over 27, substitute 6 and negative 6. So answer is also 32. When you take the rectangle minus the blue color, the answer also 32. Can you see it's the same? Okay, right. So far, any question?
So
No. Yes. What is your
where
question?
where's the 4 come from?
4,
After we integrate 3x to the power of 1 over 2.
3 to the power x of 1 or 2. Okay. I go to this one here. Okay. So you integrate this one. This one is referring to this area. You look at my arrow, from here until here, this x-axis, and go up again. This part here. Only this part. this part cannot find. You only, because area under the curve, between the curve and the x-axis only, so you only found this part. The bottom part you cannot find. So this is from 0 here, here 0 until here is 4. From 0 to 4. So from 0 to 4 is only this area here. The bottom one cannot find. So in order to cover the whole area, you find the top, multiply by 2, then you get both the area. Any more question, Karin? Karin? Okay, no? Yeah, Karin, any question? No. Farish? No. Farish? Farish, any question? Farish also no question. Okay. So that's all. We look at the second question here. Now the second question is this part, this shaded part here. Like tajam like that, no? This part, okay. So this area is between, you want to find using area between the curve and the y-axis, or between the curve and the x-axis. Now I want to tell you that this area here is not between the curve and the y-axis, because if between the curve and the y-axis, you will come until this area here also covered, no? Now this one between the curve and the y-axis is actually between the straight line and the y-axis. It's not between the curve